So hello everybody, welcome to OneClass. My name is Shanjida, and today I'll be going over some commonly asked math questions, both at the high school / university and college levels. And I'm currently a second year human biology student studying at U of T. And lastly, if anyone needs additional schoolwork, help, or needs tutoring, you guys could check out the description box below. And other than that, we'll get started. So our first question here says, how do I find the inverse of e to the power of x? And so basically we can solve this by swapping or interchanging the x and y variables. And what we mean by this, you're just taking the inverse. And so what we do is basically you interchange the variables. Okay. And the way we do this is by, so we have our equation, our normal equation, where a normal exponential function looks like y is equal to e to the power of x. And we can basically change the variables or swap the variables, where now our x is equal to e to the power of y. Okay, and now what we have to do is take the natural logarithm of both sides. So next step would be to take the natural log, which is your ln, natural logarithm of both sides. Okay, and so now what we have, we will basically have ln of x is equal to ln of e to the power y. Wait. This have ln of e to the power y. Okay, and so note that since this is ln e to the power of y, we can say, since this is ln of e, this basically cancels out. Okay, that note ln e power of y is equal to y, right? Since this cancels out, ln times e to the power of, ln times e is basically, they're like the inverse of each other, so they cancel out. And so lastly, what we have is we have ln of x is equal to y. And so therefore we can say, therefore the inverse of e to the power of x is y equal ln of x, or ln of x is equal to y. And we should also know that the inverse of the exponential function is the logarithmic function, and the natural logarithm of the natural logarithm is a logarithm function with base e, right? And which is your Euler's number. So I'm gonna write that down. So inverse, this is just a side note, inverse of exponential functions is the logarithm function. Logarithm. And so whereas the natural logarithmic function is basically this function is a log function, with base e, which is Euler's number. Okay, and so this is what I've stated here, and so therefore the solution is correct. So our next question says how to factor a cubed minus b cubed. Okay, write this down. A cubed minus cubed. How to factor. Okay. And so basically we're given a polynomial, a difference in of polynomial of two cubes, and it can be factored based on the identity as so a cubed minus b cubed. There's a formula for this which says it's a cubed minus b cubed is equal to a minus b times a squared plus ab. Okay, so basically this is your factored form of a cubed minus b cubed. Okay, and so as you can see, so this is basically a formula, and if you want to FOIL this out, you would get a cubed minus b. The solution okay. Next question. We have how do you simplify x minus 3 squared? Okay, so like we just previously discussed, this is a we can so basically what we want to do okay, so it says how to simplify x minus 3 squared. So you have x minus 3 squared, right? And if you guys recall that this resembles a formula that is a minus b squared, right? And so you guys recall the formula for a minus b squared, which is a squared minus 2ab plus b squared. So we're just going to use this formula and simplify x minus 3 squared. And so we can basically say let x equals to a and b is equal to negative. Okay. So from our equation, we can say that x minus 3 squared is equal to x squared minus 2 times x minus 3 plus negative 3 squared. So you further simplify this, you have x squared plus 6x, right? So negative 2 times negative 3, you would have positive. You have an x, and you would have plus, right? And so what you basically have is that x minus 3 squared is equal to x squared plus 6x plus 9. Okay. So I think they use the cubic formula here, which it does not ask since it's a square. So the answer is is squared squared plus 6x minus 3 squared is equal to next question we have is how do you simplify e to the power of ln of x? Okay, so the definition of a ln function is that, or it is also called a natural logarithmic function. So, a natural logarithmic function is defined is defined by the logarithmic function make function with base e. And so in another way to say this is that you have ln of x, let's say ln of x, this is equal to log x, this is equal to log base e. Okay, so this is what we mean by our logarithmic function of base e, and this is equal to ln x. Okay. So there's a property of your natural logarithmic function. So property is that you have e to the power of ln of x is equal to x. Okay, this is because your e and your ln function is basically the inverse, or basically the opposite. So when you have them together, it would basically cancel out. And so to prove, let's say, so since we said we need to simplify e to the power of ln of x, so to show this in steps, so question says, let's prove that y is equal to ln e to the right. And so what you need to do is so what we need to do is multiply ln to both sides. To both and so what you have is you have ln of y is equal to ln of e to the ln of a. And so what you have is, using the properties of logarithm functions, we can bring down the exponents. And what we have is So what we get is we get ln of y is equal to ln of x times ln of y. So we just brought ln of x down. And we know that another property, we know that we know that ln of e is equal to 1. Okay. Ln times e is equal to 1. And so, having said that, we have ln of y, right? Is our equation, which is ln of y is equal to ln of x times ln of e. You can say this is equal to 1 right, x. Ln of x times ln e times 1. And so your ln on both sides would get cut off. And so what you're left with is just y is equal to 8. And so therefore, we can say that e to the power of ln of x is equal to x. Not difficult, so the solution here is correct. Okay, so our next question says, what is the value of x in ln of x, which is equal to 2? Okay, so let's write down the equation. It says ln of x equal to 2. And so what is x equal to? Okay? And so to get rid of the natural logarithm, we make both sides of the equation as exponents of e, okay, to get rid of the ln. So if you guys recall the property where you have, let's say recall, you have e to the power of 1 of x, which is equal to x, right? So what we can do is, so we can say, so we have x equals to e to the power of 2. Okay, right? So e to the power of our, which is what it is equal to. We know that x is equal to e to the power of what, ln of x, and this ln of x is equal to 2, right? So let's just say x is equal to e to the power of ln of x, which is equal to 2, right? So we just substitute that in. So ln of x equals to 2. So we have x is equal to e to the power of 2. And so if you further simplify this, you would get x is equal to, as it's approximately equal to 7.3891, which is basically e squared. And so the solution is correct. Okay, so our next question says, what is sine of x plus cos of x in terms of sine? Okay, so what we need to do is, if you guys recall the Pythagorean theorem, they recall the Pythagorean theorem, or the Pythagorean theorem, where this was, you guys recall, which was b squared equal to a squared plus b squared. And from our trigonometric identities, we know that cos squared from trigonometric identities. Let's recall that cos squared plus sine squared x is equal to 1, right? So this is kind of like our Pythagorean theorem. And so to basically, what is sine x plus cos x in terms of sine? So our answer has to be in terms of sine. And so what we can do is, so since our answer needs to be in terms of sine, we need to make an equation that cos, for in this case, cos is equal to sine, right? And so what we have is, if we isolate cos squared x, we just move sine squared x to the other side. So we have cos squared of x is equal to 1 minus sine squared of x. And since we want our terms in sine, what we do is we have to square root both sides to cancel out, or to basically cancel out the square. Okay, so we square both sides, and you're left with cos x equal to plus and minus 1 minus sine squared of. And so, however, or I think, sorry, I think it's, if it's in terms of sine, I think you have to write the answer is so sine is equal to, so I think we just did the opposite. So what we have to do is, you guys will call it cos squared x plus sine squared x is equal to 1. So let's isolate for sine squared x. And you would just move cos squared x to the other side, right? So you have sine squared x is equal to 1 minus cos squared. You square root both sides, cancel out the squared. We have sine of x is equal to plus minus 1 minus cos squared of x. Okay, so this is your answer, where sine is equal to the answer, right? So this would be there. So it would be sine of x is equal to plus minus square root of 1 cos squared x. so our next question says, how do you solve for h and a is equal to half b times h? Okay, so this is your formula for the area of a triangle. And so you guys, I'll just draw out a triangle here. So we're trying to find out the area of a triangle. And so the area of a triangle, so this is your base. So the area of a triangle is equal to half times base times height. A half, as in you have, so your height is formed by this diagonal line, which basically halves the triangle into two parts. You have half times base times height. Okay, so b is for base, h is for height. And so what we're trying to do is solve for h from this equation. And so what we can do is, what we want to do is basically isolate h and move whatever is attached to it to the other side. So one way, so I'll just write b. And what we want to do, so let's first get rid of the half, and to do that we multiply both sides by 2. So got rid of the 2 here, and you're left with b times h, 2a. And so what you have, the next thing to do is to move the b over, and to do that we divide both sides by b. You're left with 2a over b by b is equal to, right? So let's say h, so h is equal to 2 times your area over your base. Okay. And so this is answer for the solution. Okay, so the next question says, what is the factored form of x cubed plus 1? So what or what are the factors? Or yeah, what is the factored form of, so it's basically cube plus 1. Okay. And so if you guys recall that x cubed plus 1 resembles a formula which is a cubed plus b cubed. Okay. And so the formula for a cubed plus b cubed was a plus b times a squared minus 2ab squared plus. In this case, it's plus. And so a squared, okay. Yeah. No, I think sorry. So this is supposed to be an, okay. So and so what we can say to find x cubed plus 1, the factor form, we say, let x cubed equal or x. Okay. No, actually x cubed is equal to a cubed. Cubed is equal to a cubed. So this means x is equal to a. And let's say b or 1 is equal to cubed, which means 1 is also equal to. Since we know 1 cubed is just 1. And so therefore we can say x cubed plus 1 is equal to x plus 1 times x squared minus 2 times x plus 1 squared. And so to further simplify this, you have x plus 1 times x squared minus 2x plus 1. So we simplified, so the factors of x cubed plus 1 is x plus 1 and x squared, x squared minus 2x plus 1. However, since they're telling us to find the factor, we can factor this even more. And to do that, so let's say so factor x squared minus 2x plus 1. Okay, and you guys can probably remember the factoring rules, where you have to find a number that we have to find two numbers which, if we multiply, would give you 1. Okay, and if you add or subtract, it would give you negative, right? Oops. Multiply. If you multiply, it would give you positive 1. And two numbers that if you add / subtract, give you negative 2. In this case, the only two numbers that if you multiply would give you positive 1 are negative 1 and negative 1. And so we can say that we can use these two numbers to factor out this trinomial. And so therefore we have x squared minus x minus x. Okay, now we just factor out an x. We have factor out a 1 and okay, so our comes is x minus 1. Okay, so this is basically x minus 1 squared. Squared. Okay, and so therefore the factors for x cubed plus 1 are x plus 1 and x plus 1. Okay, and this is okay. So our next question says, how do you solve 2x? So this inequality, 2x less than 8, 2x. And so to solve this inequality, we just basically, we're trying to solve for x. And we basically divide 2 to basically get rid of 2 that is attached to the x. You can say this, divide this by 2, divide this by 2. So you have x is less than 1. And so hence the solution given to you is that the inequality, so the inequality or solution. The solution 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 to the inequality is this is 2x greater than and is so this is okay. So our next question says, how do you verify the expression cos of 800 minus 200 using sum to product formula? And so there's a trigonometric formula for this, if you guys recall. Which is cos of x minus cos of y is equal to minus 2 sine of x plus y times x plus y over 2 over 2 times sine of x minus y over 2. Over 2. Okay. So this is a formula, and so we're going to use this to find the to verify that the expression cos of 100 minus cos of 200 is equal to sine of. And so in this case, what we would do is so what we would do is let cos of x is equal to 100. So let's say that cos of x equal to 100. And y is equal to 200. So what we're going to do is basically put this into a formula. What we would have. So basically cos of 100 minus cos of 200, which is your y, is equal to negative 2 sine times 100. Or sorry, so in this case, this would be x. Negative 2 sine of 800, which is your x, plus 200, which is your y, over 2 times sine of 100 minus 200 over 2. So just substitute x is equal to 100 and y is equal to 200 into the equation. And so what we do is just further simplify this. And over here, we have what we would have is we would basically, so if you do the math here, it's going to simplify the fraction. So you have negative 2 sine of 300 over 2 times sine of negative 100 over 2. So you basically have negative 2 sine of 150. So 300 divided by 2 is 150. Okay, 150 degrees times sine of negative 50 degrees. Okay, and if you guys, so this, we can write 150 another way. So 180 degrees minus 30 degrees, right? So this is another way of writing 150 degrees. And so then you have sine of degrees, right? I can't really write negative 15 in another term. If you guys, so there's another property, if you guys recall that, so recall that sine of 180 degrees minus theta, which is an angle, is equal to sine theta. So this angle right here, okay? And so in this case, what we can say this is equal to negative 2 sine. In this case, theta is 30 degrees, right? So if you resemble this formula right here, our theta is 30 degrees times sine, what we have is negative 15 degrees, right? And so from our special angles, recall that sine of 30 is a half. So we just substitute a half here. So we just substitute a half, and you have sine of negative 50 degrees. And if you guys also recall another condition formula that recall that negative sine of negative x is equal to sine. Okay, so in this case, what we can say that so basically for this we can say, so this resembles, so this right here resembles negative sine of negative x. Okay, then negative sine is right here, this part, and negative x is this part. And so what we can say is, and it's equal to sine of x, so sine of x would be just sine of 50. And so what you have is cos of 100 degrees minus cos of 200 degrees is equal to sine of 50. Okay, so we just prove that. And so this is the answer. So this. Next question says how to find the exact value of cos pi 5 pi over 6. Okay, so we have here cos of 5 pi over 6. Okay, so what we need to do is first determine the coterminal angle of 5 pi, and we basically subtract 5 pi continuously to get an angle between pi over 2 and basically 2 pi, or pi and pi over 2 and 2 pi, which and so to do this we just subtract 2 pi from 5 pi until we get pi. So what we have is, so what we do is we subtract our 5 pi by 2 pi. So to find our angle, so we have, so the angle basically 5 pi minus 2 pi, which is 3 pi. Maybe subtract this by 2 pi, which is pi. And so these are related angles, you could say. And so in basic trigonometry, we know that cos of pi is equal to -1, right? So we can also say, so cos of 5 pi is also equal to -1. So now to substitute the given, the last step would be to substitute the given value to the expression. So substitute either one into expression. Okay, so you have cos of 5 pi 6 is equal to -1 over 6. That's correct. Okay, so next question is, the question that we have is the cup. So our next question says to convert 30 degrees in radian. Okay, so there's a conversion factor where you do degrees times pi radian over 180 degrees. Okay, so in this case, we're trying to convert 30 degrees to radians. So we have 30 degrees times over 180. And so we can basically say this is x. So you have pi over 6 radians. Radian. Okay, solution here is Okay, so our next question says, what does secant of pi over 4 equal to square root 2? So let's recall the definition of a secant function. So we know that secant of theta is basically the inverse or the reciprocal of cos theta, right? And so we can say that secant of pi over 4 is equal to 1 over cos of pi over 4. Okay? And so now so from the unit circle, we know that cos, if you guys remember the special angles, pi over 4 is equal to the square root of 2 over 2. And so I draw the triangle here, a right angle triangle. Oops. Go here. Okay. Let's say this is a 90 degrees. This is 45. This is also 45. Okay. This is our hypotenuse, right? The longest side. So this is, you guys remember square root 2. This is 1 and this is 1. And so cos of 45 which is basically pi over 4, is, it's adjacent over hypotenuse. So adjacent would be 1 for your hypotenuse, which is square root of 2. Or, yeah. And so this is basically the same thing as saying square root over 2. So in this case, cos pi over 4 is equal to cos of 45. Okay. 45 degrees. And so from this, right, our triangle here, we know that cos of 45 or pi over 4 is square root over 2. And so what we can say, so thus we can say that secant of pi over 4 is equal to 1 over cos of pi over 4. Right, and this, so we just substitute pi over 4 is equal to square root of 2 over 2. So you have 1 over square root of 2 over 2. And this is, so you just flip this over, so you have 2 over square root of 2. Okay. And so the last step would be to rationalize. So you just rationalizing what we have 2 over square root of 2, and to basically cancel out the square root of 2 in the bottom, we multiply the square root of 2 with the numerator and the denominator. And what we have is 2 square root of 2. And if you have a square root, the same square root multiplying each other, you have, so basically have square. And so since the square and the square root are inverse of each other, they cancel out. And so you basically have 2 square root of 2 over 2. So you know that your 2's will cancel out here, and you're left with square root of 2. You're left with square root of 2. And so, therefore, your closing statement. Therefore, secant of pi over 4, which is basically the angle 45, is equal to square root of difficult here. So this is and so that was basically the end of our session. If you like this Q&A, please subscribe to the OneClass channel, like, share, comment this video. If anyone needs one-on-one tutoring sessions or has a specific question they want to ask about the related topics, you guys could check the description box below and follow the links to ask your questions. Other than that, I am Shanjida, and I hope to see you guys soon. Bye bye.